So today we're going to do the graphs of cosecant and secant. So the graph of cosecant is going to look like these parabola shapes. However, in order to graph the cosecant graph, we're going to need to first graph the sine graph. Because remember, and what you're used to seeing is the abbreviation CSC for cosecant. Remember, cosecant is the reciprocal to sine. So what we're going to do is graph the sine graph first, then we're going to add in some asymptotes, and then we're going to add in some parabola shapes. Now, just to show you how this comes about, so for example, you will graph the y equals sine of x or sine of theta graph first. But if you think about it, how we're getting these order pairs, if you think about these quadrant angles, remember here is 0 and 2 pi. Up here was pi over 2. Over here is pi. And then 3 pi over 2. And then if you remember the order pairs that it's associated with is 1, 0, 0, 1, negative 1, 0. And then this one was 0, negative 1. So just like before with the sine graph, remember when you did, say, for example, sine of pi, you'd come over here and remember sine looks at y. Originally it was y over r, but now we're just looking at y. But if we took it, it's 0 over negative 1. And then here, what we would do is, you know that anything, 0 divided by anything is just 0. And then if you did the reciprocal of cosecant, remember you flip it, r over y, 1 over, negative 1 over 0, and this is undefined. So remember, whenever you're going to do this, whenever your sine graph, when the value is when the value of the angle is an x-intercept, for the cosecant graph, it's going to be undefined, and we're going to have asymptotes located at all of these undefined points. You could do look at the same thing for sine of 0. So when you did sine of 0 radians, remember that is 0 over 1. And again, this equals 0, but for cosecant of 0, this is going to be 1 over 0, which again, undefined or no solution. And again, at both of these points, it's going to be an asymptote. So if you look at it, let me zoom in here. So what we're going to graph first is the sine graph. Remember, the sine graph, the first point is always at 0, 0. Then from there, it'll go up to positive 1 at pi over 2. Then back at pi, it equals 0. And then at 3 pi over 2, sine is negative 1. And then back at 2 pi, it's back to 0. And then you can complete it on the other side. So you're always going to graph the sine graph first. Let me go ahead and finish this. And at these maximum and minimum points, we're going to be adding in parabola shapes. But the first thing you're going to do, and you're going to show me this when you graph these, you're going to show me the asymptotes. So at every place where your sine graph touches the x-axis, you are going to draw in a vertical asymptote. So all of these are our asymptotes. And then to get the cosecant graph, at each maximum, you're going to draw in a parabola that is going to use those asymptotes as guides. So what you would draw in here, you would put a point on, let me do it in a different color than blue so it shows up. So at this maximum point, you're going to draw a parabola using the asymptotes as a guide. Then at the minimum, you're going to draw a parabola facing downward. And here's another maximum rising up. And then the other minimum. And there's your U shape. This is actually 2 cycles. So remember, a normal cycle is normally pi. So over here is 1 cycle, and over here is 2. So on the test, you are going to be giving me 2 full cycles when you graph these. So you'll get 1 to the left and 1 cycle to the right. So let's go ahead and look at the secant graph. And we're going to do the same thing. We're going to graph the cosine graph first. Remember, the cosine graph always starts at 1 unless there's an amplitude. And then from there, it'll go down at pi over 2 to the x-axis. And then at pi, it goes to -1, 2 pi back to 0. And then finally at 2 pi, at 3 pi over 2 is at 0. And then at 2 pi, it's back to 1. And again, complete the cycle. So this is 2 cycles. We have 1 here. And then another one over here. So this is 2 full cycles of the sine graph that I just did in red. Now, to graph the secant graph, what we're going to do is draw in the asymptotes. Every place that that red graph touches the x-axis is where an asymptote is located. So I have one here at -3 pi over 2, one at -pi over 2, another one at pi over 2, and then the last one at -3 pi or +3 pi over 2. Again, remember, here is my cycles, 2 of them. It goes from -2 pi to +2 pi. Again, I got a cycle right here and then another one right here. Now again, at each of these maximum and minimum points, you're going to add in your parabola shape. Now notice here, you've only got part of it. The other part would have been over here, but that's out of my cycle. I don't need to see that because I only want from 0 to -2 pi and then from 0 to 2 pi. And then over here at this minimum, your other parabola, here's a maximum, minimum. And again, for this last little piece, the parabola would have been here. But I don't need to see this piece or this piece because it's out of my 2 cycle box. So let's go ahead and let's practice first graphing a sine and a cosine, and then we're going to add in the asymptotes and then the U shapes. So, or the parabola shapes. So first thing we're going to do, this one, is we're going to graph the reciprocal to secant, and that's going to be cosine. So remember, the 2, this is my amplitude. Remember, for the amplitude, all we need to do is label that y-axis. However, this 1/2, this is going to tell me if it's going faster or slower. So this is actually going to go slower. And again, you take this and you're going to take 2 pi and you're going to divide it by 1/2. Again, since this is division, I'm doing keep, flip, change. So this is really 2 pi divided by 1/2. So 2 pi, keep, flip, change it. And it's 4 pi. So notice now, in order to complete the cycle, it's going to take me up to 4 pi. It's going to be a lot slower. So again, since it's not a phase shift, we take that cycle or that period length and we have to split it into quarters. So 4 pi times 1/4, 4 pi times 1/2, 4 pi times 3/4, and 4 pi times 4/4. The 4's simplify, so I just get pi. This also simplifies, 2 pi. This simplifies, 3 pi. And then lastly, 4/4 is just 1, so 4 pi. Again, remember the left side of the y-axis is just like a reflection. So all of these same coordinates here, or my labels for the x-axis, are going to be the same. They're just going to be negative. So now let me graph the cosine graph first. Then I'm going to graph the reciprocal. So let me add in an x and a y-axis. I don't have graph paper on this, but I'm just going to space them evenly. So my first point is at pi. Then I have one at 2 pi. And then I have one at 3 pi. And then 4 pi. Over here, negative pi. Negative 2 pi. Negative 3 pi. Negative 4 pi. I also add an amplitude. So I'm going to go ahead and put in my amplitude of 2. And now I'm going to graph the cosine graph first. So remember, cosine normally starts at 1 on the y-axis, but because it has an amplitude, I'm going to start it at positive 2. And then from there, at pi, it's coming down, and it touches the x-axis. And then at 2 pi, it's down here at the negative 2, back up, and up again. Complete the pattern on the other side. And add in your little waves now. So this is what you did in the homework last night. This is just the graph of the cosine. Now to graph secant, every place that my blue graph touches the x-axis, I'm going to draw in green asymptotes. So I have an asymptote here at negative 3 pi. I've got one here at negative pi, one at positive pi, and one at positive 3 pi. Now my cycle is this box. So if it helps you to draw a box around it, you can. You don't have to. All right, so now at each of my maximum and minimum points, this is where I add in my parabolas. So up here, if it helps you to see the other half of the U, you can put it outside the box, but just know that I don't need to see that in the final answer. And then again, at this minimum, use the asymptotes as a guide and put in your parabolas. And then up here, and down here, and then here as well. Again, if you're not sure how to make the U, do the whole U. And then just remember, you can just, I guess, put shading over it or whatever. Because again, sometimes when you start to erase, it gets kind of messy. So let me undo the stuff I don't want to see. I could do that in purple maybe instead of yellow so it shows up. Change the color. And why does it not keep that color? Sorry. I don't know why my highlighter's not changing. All right, so so the final graph, so if you want to do this in color, you could just say the final graph is in red. So what you can do is, I don't need to see the blue anymore. If you want to erase it, you can, or you could just do a little scribble over the stuff that isn't the final answer. So the final answer is in red. I do need to see the asymptotes graphed as well. Pretty good. Now let's do a reciprocal of sine. Let's do a cosecant graph. Pretty good. So what we're going to originally graph is going to be y equals the reciprocal, so negative sine x minus pi. Now this one's got a phase shift, so at least we can get an example where we're shifting it to the left or the right. So for this one, notice the negative sign here. So this is a negative sine curve. So instead of going up to +1, I'm going to go down to -1. And then here, the minus pi, backwards of what you would think, I'm shifting it to the right, pi radians, or 180 degrees. So again, remember for this one, we're not going to do the 1/4, 1/2, 3/4. We're actually going to space it 90 degrees apart. So what I'm going to do is take my, starting at pi, I'm going to add pi over 2, 90 degrees. I need to find a common denominator. So this will end up being 2 pi over 2 plus pi over 2. And this becomes 3 pi over 2. Then I take the 3 pi over 2. I'm going to add how I already found it. It's got the common denominator, pi over 2. This becomes 4 pi over 2, which is just 2 pi. Again, I need to get 4 points where I'm adding pi over 2. I'm going to take the unsimplified 4 pi over 2, add pi over 2, and I end up with 5 pi over 2. And then do the next one, 5 pi over 2, add pi over 2, 6 pi over 2, which is just 3 pi over 2. These are my 4 points that are going to be to the right of my starting point. Now I have to find 4 to the left. So again, I'm starting at pi. So again, as the common denominator, I'm going to change pi into 2 pi over 2. And I'm subtracting this time to get my left side. So once I do this, I get pi over 2. Take pi over 2, subtract pi over 2. Notice that I get a 0 here. This tells me I will stop on the y-axis for this one. And then 0 minus pi over 2, negative pi over 2. And then I need to do it one more time. Negative pi over 2 minus negative pi over 2, negative 2 pi over 2, which is just negative pi. These are my 4 points on the left side of the graph. And again, I'm going to graph this sine graph first. This is what you did for homework. Then I'll add in the asymptotes and then add in the parabolas at the maximum and the minimum points. So let's go ahead and make my x and y axis here. Going to try to space them all out nice and evenly. So I have 90 here, pi over 2, and then pi. And then I have 3 pi over 2. And then I have 2 pi. 5 pi over 2. And then lastly, 3 pi. Over here, I'm going to have negative pi over 2, negative pi, and that's it. My graph looks lopsided, but you have to remember our starting point is right here. And remember, the y-axis was one of the points. So I actually have 4 points right here, including the 0 is one of my stopping points. And then I have 4 points over here. So it makes sense, even though it looks lopsided. So now let's go ahead and graph the sine graph. It's a negative sine graph. Remember, sine starts normally at 0. So I'm going to put my first point at pi, because that was my starting point, on the x-axis at 0. But now instead of going up to +1, because it's a negative sign, I go down here to the -1. And let me add in, this will be 1, this will be -1. So my next point at 3 pi over 2 is going to be at the -1. And then back up to 2 pi. And then at 5 pi over 3, it's up to the 1. And then the 3 is right there. Now this is one cycle. Again, look how far it's shifted over. And then I'll finish up the cycle, moving towards the left. So then at pi over 2, it's up here at 1. I do stop on the y-axis. And then my next point is at negative pi over 2. And then here. So there's my graph. This is the sine graph. And again, if you want to box it in, you can. So let's add in our asymptotes. I've got an asymptote right here up negative pi. Got another one, which is my y-axis. Got one here at pi. Got one at 2 pi. And then one at 3 pi. And now remember, at each maximum and minimum, we're going to add in our parabola shape. And again, the blue is the final graph. This is the final answer, is the blue. And again, use the asymptotes as guides and add in your parabolas. And that is the cosecant graph with a shift of pi to the right. So again, you're first going to graph the reciprocal, either sine or cosine, and then add in the asymptotes and add in the parabola shapes. So again, if you just want to either color code it, if on the test when you're graphing this by hand, if you just want to shade over, like with your pencil lightly, and say that the red shouldn't be there, you can do that. I do have colored pencils I could pull out if you prefer that. Only problem with the colored pencils is sometimes they're tough to erase. So again, if you just want to like slightly shade over the sine graph, which is what you use to set up for your cosecant graph.